All right, so now I'm going to demonstrate how sterile technique works. The basic principle behind sterile technique is that although you can't see it, everything around you is covered with microorganisms, all sort of little bacteria, spores of fungus, virus particles. They're everywhere. Every single surface is covered with bacteria. The air, there are bacteria floating through the air. Some people get overwhelmed and when they start thinking about this. It's not really a problem for us. We actually need bacteria in our environment to be healthy. It wouldn't be healthy to just live somewhere with no microorganisms around us. But when we're growing cells, we need to be very careful to keep them from contamination. Inside your body, you have an immune system to protect you. But when we're growing cells in a dish, say cells taken from a mouse, they're outside of the mouse. Now they don't have an immune system protecting them anymore. So we have to protect them. And we do that in what's called the biosafety cabinet. The biosafety cabinet is a sterile environment. Everything in here is supposed to be sterile, no microorganisms inside. I'll give a few principles of sterile technique. The first one is that anything unclean that touches something that's clean, the clean thing becomes unclean. It's kind of like how it works in Leviticus and Numbers back in the Old Testament with the Levitical system, all of the rules that God set up back then. They were supposed to teach the people about sin and point forward to Jesus, but it was the same basic principle. This is part of why it was so amazing, the miracles that Jesus did. Normally, if you went and you touched someone who was a leper, he was unclean, and so you would become unclean. But the opposite happened with Jesus. When Jesus touched the leper, Jesus didn't become unclean. The leper was cleansed, right? So it's the whole thing working in reverse. So we're not Jesus, so that's not how it works for us. Anytime something unclean touches something that's clean, or to use modern language, anytime something that's not sterile touches something that's sterile, the sterile thing is no longer sterile. So let me demonstrate how this works. This is the biosafety cabinet. Just for the sake of the video, to reduce the noise, I've actually turned it off. But the normal way it works is that this piece of glass called the sash protects everything inside. So when I'm ready to start working, I'm going to take the two handles and lift up the sash. And you can see these little marks on either side of the biosafety cabinet. This is the closed mark. This is the open mark. And you want to open it to exactly where the marks are. If it's not where the marks are, the cabinet will start beeping at you just to remind you of where it's supposed to be. Once I open it, if the cabinet were on, you would hear the air start flowing, and that shows that it's working. Perhaps you've entered a big store like Costco or Walmart where there's a big bay door that everyone enters through, and it's pretty much always open, but they don't want to lose lots of heat in the winter, and so they have kind of a wall of heat blowing down across the doorway to keep the air inside separate from the air outside. And that's basically how it works. It's called a downdraft system. There are fans up above with some filters that filter out bacteria and all sorts of particles. And then down here, this is under a vacuum, and so there's a wall of air constantly rushing down to separate the things outside from the things inside. Anytime something moves from the outside to the inside, we need to sterilize it, and we do that with our 70% ethanol. So we want to keep a nice, clean working environment, try to keep as few things in the hood as possible. That just helps us keep things neat, reduces the risk that things are going to bump into each other and contaminate each other. So the things I'm working with today, I'm going to put them in, and sometimes you'll see people just kind of give something give it a ceremonial squirt. Well, that doesn't really sterilize it. To sterilize it, you need to hit all the surfaces, and so I sterilize the whole thing. If you want to try to save ethanol, you can do multiple things at once, kind of do the front and back, put them in. Same thing with my serological pipettes. I kind of give a lot of little squirts so I can cover the whole surface without using up too much ethanol. And I place everything inside. And once I have everything inside, I'll want it to be nicely arranged, so I just have a nice working environment. So if you're left-handed, everything would be reversed, but if I'm right-handed, usually instruments that I'm going to be just working with to pipette things, such as the controller for my serological pipette I place over here. It would probably be good for me to take my stand of micropipettes and have them over here. I can take my serological pipettes and think about which end is the top and which is the tip, and have the tips pointing away from me, just so they're all ready to go. My cells that I'm going to be working with, I have here in the middle. Usually over to the side, I might have empty vials, things that I'm working with. I just kind of try to spread it all out in a nice, neat row, such that everything is easily accessible. So now for some tips for how to actually operate inside the biosafety cabinet. So anytime that I put my hands in, I need to make sure that they're sterile. So I usually squirt my hands, rub them front and back to make sure the ethanol kills everything. The basic rule is nothing should touch anything else. So even though the inside of this cabinet is sterile, we think of there being different levels of sterility. So the highest level of sterility is, for example, the inside of maybe a plate where you're growing cells, the actual surfaces that you're growing them on. Certainly the insides of any bottles that are going to have any sort of media or anything that we add to the cells. The tips of your pipette tips, those are the things that are most sterile. It's kind of like, I don't know, the Holy of Holies back in the tabernacle. Then there are things that are slightly less sterile. So for example, even though I've sprayed everything down, we consider the outside of the bottles not to really be as sterile, and the outside of the tips box, and the outside of the cells, and my gloves, even though I sprayed them. The whole inside of the biosafety cabinet, the walls, the sash, I don't know what to call it, just the surface of the biosafety cabinet. By the way, one thing that I forgot to do that you should do at the beginning is, before you do anything else, it's nice to just spray down the actual biosafety cabinet itself and let the ethanol sterilize everything. Sometimes after you've let it sit for a while, you can take a paper towel and kind of wipe it down, but I omitted that step. Okay, so back to nothing touching anything else. Basically, this means I can pick up a bottle, but I don't want to reach in and touch the inside of the bottle. I can touch the outside of this 24-well dish where I'm growing cells, but I don't want to reach in and touch the inside. I don't want to touch the inside of the lid. I don't want to reach down and touch the inside. Nothing should touch anything else. So I'm just going to demonstrate a few techniques. The basic principles first are nothing should touch anything else unless absolutely necessary, because touching is how the bacteria get transmitted. Number two, just remember gravity. Things tend to fall down, right? Dust tends to fall down. The same thing with bacteria. So nothing should pass over anything else unless the lid is on. So for example, if I take the lid off, I'm going to try not to pass my hands over this dish where the cells are growing. I'm going to maybe move my hands in front of the dish so that if some bacteria fall down, some little dust falls down, it doesn't fall into the container. Same thing with this bottle of culture medium. I'm going to leave the lid off for as little as possible, but when I do take it off, I'm going to try not to just gratuitously pass my hands over the top of the bottle. I'm going to try to return the lid on as soon as possible. So let me just demonstrate a few techniques just to show what this looks like. Let's say I'm going to transfer some plating medium into one of these conical tubes. So I'll just bring the tube here, and I'll think in advance about everything that I want to do. There's not a rule, should the bottle go to the left, should it go behind, should it go to the right? It doesn't matter very much as long as you can easily access everything and try not to have things crossing over and bumping into each other. But I think this will work well for me. Once I pick up the serological pipettes, I'm going to run out of hands. So I don't want to take this off in advance because I want to leave it on for as much as possible, but I do want to at least loosen my lids, because if it's on really tight, it can take two hands and it can be hard to do once you're holding a bunch of other things. So I'm going to loosen the lids, but just leave them on. Then I'm going to open my serological pipette. So it's very important to always open it from the top. Again, the tip we want to keep really sterile. Right now this is in sterile packaging. Everything inside is sterile. It's okay if I touch the top of the serological pipette. I definitely don't want to touch the tip and contaminate the tip, because the tip is what's going down into the plating medium that's going to then come in contact with my cells. So I open it up. There are two nice little tabs here, and you can just kind of, oh, you know, I should have pulled this up so it's easier to see. I'll just pause for a moment. Is that okay, do you think?
Yeah, it's okay.
All right. Okay, so I'm going to pull open, and I just pull it apart. I don't need to pull very much. I just expose it a little bit. If you have any trash, you can set it down to the side. And notice that I was actually able to do that without even touching the serological pipette at all. So I then take my controller and I firmly press it in. I slide off the cover. And now I want to be very, very careful not to touch the tip of this to anything. It shouldn't touch the floor. It shouldn't touch the outside of my bottle. It shouldn't touch my glove. If it touches anything at all, take it out, throw it away, start over with a new one. These aren't cheap, but better to lose one than to ruin your whole experiment from something getting contaminated. So now I'm ready to take up some plating medium. So I'm going to lift open the lid. Now when you lift off the lids, don't turn them upside down. Don't do what I'm doing. Dust could fall down and touch this, and now it's on the inside. So when I take it off, I'm going to leave it facing down. You could just hold it in your hand, or if you need to set it down, you can set it down like that, but notice it's protected from dust falling inside. So I reach down in. Now again, the rim we consider it to be contaminated, so I'm not going to touch the tip to the rim. It's okay if the walls of the serological pipette have to touch the rim. Sometimes that's inevitable when it's a narrow-necked bottle like this is. Even so, I'll try to avoid that, but I definitely don't want to touch the tip of my serological pipette to the rim of the bottle. So I reach down inside and I draw up however much I want, and I need to turn on the power. I think it won't turn on unless this is on, so maybe I'll just have to turn it back on. You know what? Here's what I'll do. I will just switch out to one where the battery is actually working. Okay. Because this one, the battery doesn't work. And this one, it does. Okay. Right, whenever you're ready. Okay, I just switched out the controller because the other one, I'm leaving the airflow off and for the sake of the video, and so the other one doesn't have a good battery, and so it has to remain plugged in to use it. So I switched it out because this one, the battery's actually working. So I draw up however much I want to draw up. All right, and then once again, as I take it out, I'm going to be very careful not to touch the tip of my serological pipette to the rim of the bottle. Let me turn that off. There we go. Can we just pick back up where we were? Yep. All right, I'm pretty sure that the just side of the serological pipette touched the rim. That's inevitable when you have a narrow-necked bottle, but I make very sure that the tip doesn't touch. I immediately put the cap back on so that the medium is exposed for as little time as possible. I take my cap off of my conical tube, and once again, I don't touch the tip of the serological pipette to the rim of the conical tube. I just bring it in, and it's okay if the wall of the serological pipette touches the rim of the tube, and then I just dispense whatever I'm trying to dispense. And then once again, when I set this down, if I'm planning on reusing this serological pipette, I make sure it cannot touch the floor of the biosafety cabinet, so I could just, for example, stand it up This one unfortunately doesn't balance on its side. That's why I like the other controller, because it stands up on its edge. So with this one we might not have any choice. But I'm just going to lean it up against here, and now we consider it kind of contaminated because it touched this dirty vacuum tube. So as quickly as possible, I put my lid back on. Once the lid is on, I can take it out of the biosafety cabinet. If the lid isn't on, that medium is now contaminated and I need to throw it away, because who knows just in 1 second what could have fallen in and could now contaminate my whole sample. But once the lid is on, I can take it out. Okay, I'll just demonstrate one other thing, which is working with cells in here. One thing I forgot to mention is that when you are using any sort of little Sharpie, these little microtip Sharpies, if you try to write on a surface that has been sprayed with ethanol, it will ruin the marker, and it might be permanently ruined. The ethanol just kind of destroys the tip. I'm not sure how. So it's a good practice to label all of your tubes, everything you'll be working with, before you spray it down and put it into the biosafety cabinet. So just a tip. Once it's inside, if it's completely dry, then you can write on things inside the biosafety cabinet. So when I'm working with cells, similar ideas. I'm going to leave this off for as little time as possible. Usually I just set it down behind it. I could set it to the side. I could have it propped up. But the idea is once the lid is off, try not to just gratuitously pass your hands or anything else over it. Let's say I need to add or take up some liquid from it. I'm going to open my tips box over here. And again, I keep this open for as little time as possible. Which one do I want? Once I take up a tip, I immediately close the lid, and I make absolutely certain that this tip doesn't touch anything. It shouldn't touch my glove, it shouldn't touch the floor, it shouldn't touch the outside of any bottle. Really, the only thing that it could touch is the inside of the dish where my cells are growing and the inside of one of these vials. Oh, see there, I was careless. I hit the bottle. Maybe I could pretend that I meant to do that just to demonstrate for you. So I say, oops, that's contaminated. Not a big deal, but I don't want to risk anything, so I'm just going to reject that tip. Usually I keep over in the side of the biosafety cabinet a beaker just to put tips and things in, or you could just set it down neatly. I'm going to go back, get another tip, press down firmly to make sure it's well seated, and now I might even push my cells a little further back so I have room to maneuver without crossing over them. I'm going to very carefully put the tip in without touching the tip to the rim or the outside of my container. I'm going to draw up some medium, and let's say I just want to add it right here. I can add it in. It's okay if I touch the tip to the inside of the well, because the tip of the tip and the inside of the well, those are both, the most sterile things, but no reason to do so if you don't have to. Oftentimes you can just eject whatever medium you're working with without anything touching anything. That's what would be most ideal. I pick up the lid, I immediately put it back on, I take off my tip, I set it to the side, I put this down here, and I put this back on. Okay, so the last thing we want to do is just to make sure that everything is clean and ready for the next person to use. So I'm going to take my serological pipette, stick it back in here, pull it out. This goes in the bio bin, of course, which is underneath. I'm going to, if there are pipette boxes that stay in here, you can just set them neatly in the corner. If they come out, you can bring them out once they're closed, of course. I'm going to take out any medium that I have left. I'm going to take out all of my trash. Everything is going to go into the proper place, whether it's the biohazard bin or anything else. Once everything is out, my cells I'm going to put in the incubator, the medium I'm going to put in the fridge. Once everything is out, I want to just carefully spray everything down with ethanol. and I'll grab a paper towel and just carefully wipe everything down with ethanol to make sure that the surface is as sterile as possible for the next user. Then I will lower the sash all the way back down to the closed position, make sure that it stopped beeping. I can push the button to turn the light off, and I am done. So that's how Sterile Technique works.